Try this one. We've redrawn the picture, now let's modify it. We start at the initial tail, which is coming from the pi bond, so we have to erase the pi bond. Now the atom at the initial tail is this one right here. It started neutral and it's losing electrons. So it becomes positive. Now, some beginning students might have been confused about whether this was the atom that was losing electrons or this was the atom that was losing electrons. But I hope that's not giving you any trouble anymore at this point. This atom here is really now in the midst of the arrows. It's losing electrons from the left, but gaining electrons from the right. So its charge is not going to change. This atom, though, is at the very beginning of the string of arrows. So when it loses electrons, there's no electrons coming back in to replace them. So I hope that it's clear to you at this point, when you're moving a pi bond, it should be clear which of the atoms that used to have the pi bond is losing the electrons. Here is this atom, which is at the very beginning of the string of electrons. This atom is kind of in the middle of the string of electrons. So what it loses on one end, it gains on the other. Hopefully at this point, you don't even have to think about that. Hopefully it should just be obvious to you by looking that this is the atom at the very beginning of the string of electrons. This is the one that's losing the electrons. We've dealt with this tail, so let's erase it. Going on to the head indicates, since it's pointing to the middle of the sigma bond, that we're forming a pi bond. I hope it's clear to you that this indicates that we're forming a pi bond and not a lone pair, because this head is not pointing to an atom. If the head is pointing directly at an atom, you're forming a lone pair. But when the head is pointing to the middle of a sigma bond, like this one, you're forming a pi bond. You should, when you're drawing your own arrows, you should try to make it clear whether the head is pointing directly at an atom or in the middle of the sigma bond, so you can see if you're forming a pi bond or a lone pair. All right, so where was I? This head told us to create this pi bond. No need to change any charges because we're in the middle of the string of arrows. Let's erase the head. Now we go on to the next tail. This tail is in the middle of the pi bond, so we erase the pi bond. We're in the middle of the string of arrows, so we don't change any charges. We erase that tail. Now we're at the final head. This head is pointing directly at this nitrogen. When you're pointing directly at an atom, it indicates you're creating a lone pair. We usually don't try the lone pair, but because we're at the final head, we have to change the charge. This nitrogen started neutral, it's gaining electrons, so it ends up with a negative charge. And now we can erase that head. So I hope you can see the difference between this head and this head. This head is pointing to the middle of the sigma bond, so it indicates we're creating a pi bond. This head is pointing directly at an atom, so it indicates we're forming a lone pair. We didn't actually have to draw the lone pair, but this negative charge signifies it. Check the charges. Originally we had 0 net charge, and in the new structure we've got +1, -1, which is also a 0 charge. Try this one. I hope you can read my handwriting. This is supposed to be a C, and this is supposed to be an L for chlorine. This is a chlorine. Let's redraw our picture, including redrawing the arrows. Keep redrawing the arrows and the picture until you've totally mastered this material, and then you can start cutting some corners. Let's look at the initial tail. It's coming from this lone pair. So we erase the lone pair. And we're at the initial tail, so we have to change the charge. Chlorine started neutral. It's losing electrons. So it becomes positive. Remember, anybody who's at the initial tail is losing electrons. Now we can erase that tail. Now we look at this head, which indicates the formation of a pi bond. We draw the pi bond. No need to change any charges. We're in the middle of the string of arrows. We erase the head. Now we go on to the next tail, which is in the middle of the pi bond. So we're moving the pi bond. So we erase the pi bond. We're in the middle of the arrows, so we don't need to change charges. All we need to do is erase this tail, because we're done with it. Now the only thing left is this head. The head is pointing directly at the oxygen, so it's forming a lone pair. We're not going to draw the lone pair, but because because this head is the final head, we have to change this charge. The oxygen started neutral, and it's gaining electrons. So it ends up negative. Now we can erase that head. Let's check the charges. Over here we have a 0 charge. Over here on the right we've got -1 plus 1, which is 0. This might be the first example that we've done with a halogen. Those are slightly more unusual examples of resonance, but they can happen as well. Notice that the fact that this was a halogen didn't have any effect on the mechanics of using the electron-pushing arrows. We just moved this lone pair just the same way we would have as if this was a nitrogen or a sulfur. So it doesn't matter whether this is a halogen or any other atom that happened to have a lone pair. And of course, we don't make any changes to the ring. We just make sure that we redraw it and then don't make any modifications, because there's no arrows coming to or from it. Try to draw the resonance structure suggested by these arrows. As usual, we start by redrawing our picture. I'll remind you again, always double check to make sure that when you redraw your picture, you're redrawing it accurately and that you're drawing the arrows accurately. This initial tail is coming from this negative formal charge. We know that means that we're actually moving a lone pair. The lone pair wasn't drawn, so we don't need to erase it. But because this is the initial tail, we have to change this charge. Here we're starting negative and we're losing electrons, so we're becoming neutral. And we can erase that tail. Whoever's at the initial tail becomes one step less negative, one step more positive, because they're losing electrons. Now we're looking at this head. The head here indicates that we're forming a pi bond. We're in the middle of the string of arrows, so there's no need to change the charges. Again, how do we know we're not forming a lone pair? If we were forming a lone pair, the head would be pointing directly at an atom, but instead it's pointing to the middle of the sigma bond, so we're forming a pi bond. Let's erase that head. Now we're looking at this tail. This tail is coming from the pi bond, so we erase the pi bond. We're in the middle of the string of arrows, no need to change any charges, so we can erase that tail. Now all we have left is this head. This head is pointing directly at this oxygen. Well, this is the situation where we form a lone pair. This is the situation where we form a pi bond, where the head is pointing to the middle of a sigma bond. This is the situation where we form a lone pair, when the head is pointing directly at an atom. We're forming a lone pair, but as usual, we don't actually draw the lone pair. This is the final head, so we need to change this charge. This oxygen started neutral, and it's gaining electrons, so it ends up negative. And now we can erase that head. Let's check our charges. Here we have a negative charge, -1, and here we have a -1. So the charges balance.